Okay, due to the rush yesterday, I decided that we should go ahead and do electrochemistry via YouTube, so let's hope we can do this. Real fast, basis of electrochemistry. It closely relates to your everyday life. You use your cell phones every day, you have a power source, an alarm clock, your clocks, everything is based off of a redox reaction, which in fact is electrochemistry. So it's a study of the interchange between chemical and electrical energy. It's concerned with two processes, and those two processes are oxidation and reduction. Oxidation is the generation of electric current from a spontaneous chemical reaction, while reduction is the use of a current to produce a chemical change. When we talk about galvanic cells, let's see if I can write this, galvanic cells, okay, there are two things going on over here. It is the chemical energy change to an electrical energy. Redox is the transfer of electrons from the reducing agent to the oxidizing agent. It can contain a salt bridge or a porous disc that connects the two solutions, and that's what I was talking about yesterday. That salt bridge allows the flow of ions, so that's extremely important. Yesterday, remember that the electrons travel through the wire, and salt bridges are used to transfer ions. Okay? It is a use of a spontaneous redox reaction to produce a current. Oxidation occurs at the anode, and when we're talking about these certain compartments, let's draw a very low scale. So I have my salt bridge that is connecting the two. One will be the anode and one will be the cathode. And when we say the anode, we're talking about the entire compartment. When I say cathode, this is the entire compartment. And then again, so we will have some type of wire source. Electrons will flow through the wire source. Ions will flow through the salt bridge itself. All right, the cell potential. So this is where I wanted to get yesterday and we ran out of time. Cell potential. It involves pulling of electrons through a wire. So your oxidizing agent is going to be your cathode. Pulling electrons again from the anode. That's the driving force. And that driving force is also known as, if you are in physics, you have seen this before, EMF. So that is your driving force. Okay, electrons need to have some type of push in order to get this started, so that's why. All right, so real fast, the EMF, or the electromotive force, is measured in volts, and 1 volt will equal 1 joule per coulomb. Okay, and coulomb was what we talked about in the last unit. All right, so when we are talking about actually figuring out redox reactions in the galvanic cell, there's always a reason.